Good morning, students. I welcome you all for another lecture on the course Computer Architecture and Organization. In this class, I am going to discuss about the concept performing arithmetic and logic operations. How my central processing unit can perform this arithmetic and logical operations with the help of ALU. That I was going to discuss in this class. So ALU is a combinational logic circuit. It didn't have any internal storage. We know that a combinational logic circuit, what it do? The combinational logic circuit produce its output only based on the present inputs. Here what I am saying is, my ALU is a combinational logic circuit. Your ALU can do so many arithmetic and logical operations based on what are the input values I was applying. According to that, it will produce as an output. So that your ALU didn't have any internal storage or a memory element. It is purely a combinational logic circuit. The second thing is about ALU. ALU is not a single circuit, it is a collection of circuits. Because the ALU can do different arithmetic and logical operations. To do addition, a separate circuit was exist internal to ALU. Similarly for subtraction, multiplication, division, increment, decrement, and doing of logical operation like logical AND, logical OR, logical XOR, complement, comparison. For doing of all these things, definitely ALU has dedicated circuits. But all those dedicated circuits are the combinational circuits. Because of that, ALU is a combinational logic circuit. Coming to the second point, it performs arithmetic and logical operations on the two operands applied to its A and B inputs. That means it is like this. Let you can assume, friends, this is my ALU. This ALU can perform different arithmetic and logical operations. The inputs where I was applying at A and B. That means I am assuming that this is my A input and this is B input. This ALU perform different arithmetic and logical operations on A and B inputs and it will produce an output. So that is the meaning of this. One of the operand to ALU is the output of mux and the other operand is applied directly from the internal bus. That means, let you can assume this is my internal bus of a CPU. So from this bus, ALU receives one of the input. Let you can assume it receives a B input from the bus. That means it will collect the data from any internal register of my CPU. In that process, it will collect the data from a register. The register places the data on this bus, and from that bus, ALU receives one input. And the second input for this ALU was, it takes from the output of mux. Let you can assume this is my multiplexer. This is a multiplexer. The multiplexer output is given to input of ALU. One of the input for this multiplexer is constant 4. Just you remember last class. So in that case I discussed the bus structure, that is the data path. In that we have this type of structure. One of the input for mux is a constant 4 and another input for this mux is nothing but output of register Y. This is a register Y. It is one of my internal register. So this A input for ALU is output of mux. It may be constant 4 but it may be the output of a register Y. That you have to remember. That's the meaning of this. So the result produced by ALU is stored in a register tab. That means, after performing either arithmetic operation or a logical operation on inputs A and B by ALU, whatever the result it was produced at output, that is simply goes to another register that was Z. That means Z register was placed at the output side of ALU. That means it is like this. This is my ALU. So the output of ALU goes to a register called Z. That's the meaning of this. For getting a better understanding, I took a small example here. A sequence of operations to add the contents of register R1 to the register R2 and store the result in register R3. That means here my operation is R1 content is added to R2 and the final result goes to R3. In order to do this simple addition, what is the sequence of operations are going on in my system? In my system, what are the different operations that is going on in this? To do this addition, R1 content is added to R2, the result goes to R3. So these are the sequence of operations. One is R1 out, comma, while. That means, see here friends, this is A input, this is a B input. So ALU collects, assuming that B input from the bus, this is my bus. And this end I have a different registers like R1, R2, R3 and so on, Rn registers. I have a number of registers. These registers are connected to this particular bus like this particular bus like this. So here one of the input for ALU is it collects from the bus, and the second input for this ALU was, that is nothing but output of mux. This is a mux. So one of the input for mux is a constant 4. This is a constant 4. And the second input for this mux is nothing but a register Y, and Y is also connected to my internal bus. So in order to do this addition, that is the content of R1 is added to R2, result goes to R3. What is the sequence of operation? So R1 out, that means here this is my R1 register. This R1 out signal, what it indicates is the content of register R1 is placed on this internal bus. So R1 out, what it indicates is it places whatever the data that value was present in register R1 onto internal bus. Comma Y, that means whatever the data was placed on this, the data must be took by this register RY, sorry, register Y. This register Y took the data what is available on the bus into it only when this signal is active. So here R1 out and Y both are the control signals. R1 out is used to put whatever the value that was placed in the register R1 into internal bus. And Y in is used a control signal to load whatever the value that was present on the bus onto register Y. So for that, by doing of a first sequence, the content of register R1 is available at register Y. That is the first thing. Second operation is R2 out, comma, select Y, comma, add, comma, Z. What's the meaning of this? So see here friends, my addition is R1 content is added to R2. This task can be done by ALU. So for that purpose, R1 value I already transferred to register Y. Through register Y, it is reaches to one of the input of my mux. Now with the help of a selection lines of a mux, I select this Y output, so that here I written as select Y. That means out of these two inputs of a mux, so this Y input was selects, that is reaches to A. That means here A value is nothing but R1 value. Coming to the second, R2 out, that means whatever the value that was present in register R2, that is placed on the bus, that is reaches to again an input of ALU as input B. So here B is equal to register R2. Then what I have to do? By selection of Y input, that is nothing but A value is equal to R1 value, and R2 out, that is nothing but a B input value. Then what I have to do is, I'll inform that ALU you do addition on A and B inputs. So after it perform addition between A and B, that means A plus B, whatever the result it was produced at output side, that was a copied onto Z. It is only possible Z in control signal is active. If Z in control signal is active, whatever the output that was present at the output side of ALU, that was copied onto Z. So what is that value now? It is R1 plus R2. But it is not a destination for our addition. We have to transfer the result to another register R3. So that means you have to transfer this Z value to register R3. For that I was doing one more operation, that is Z out comma R3 in. So this Z out is again a control signal. Its job is whatever the value that was there in a Z, that is simply transferred to internal bus. Now my result is available on this internal bus. So that value I have to transfer to destination register R3. So whatever the value that was present on this value is taken by this register R3 only when it's a control signal R3 in is active. So once R3 in is active, then whatever the data that was present on this bus, that was copied onto register R3. Like this, these are sequence of operations are performed to do addition between the content of register R1 with the R2. Final result is transferred to another CPU register R3. So that is the way how we are doing a task. Next, fetch a word from memory. So how my CPU fetch a word from a memory? That means how my CPU read a word from memory. So in that case, what is the sequence of operations that are going on and what are the internal registers are involved in that operation, that we are going to discuss in this. To fetch a word from memory, the processor has to specify the address of the memory location where this information is stored and request a read operation. What a processor must know? The processor must know, I would like to access a data from which location of the memory. The processor must know this. So after that, it has to generate a read signal. That means the first thing, it has to generate an address of memory location from which location information our CPU going to access, and thereafter it will generate a read control signal. So if I do these two things by my CPU, no doubt I can go and access the data from that selected location. Right. The processor transfers the required address to the MER whose output is connected to address lines of the memory bus. The meaning of this statement is, if I want to read something from a memory location, I know which location information I am going to read. So in that process, my CPU generated address I forced to transfer to MER. MER is a memory address register. I think everyone aware of the functionality of MER. Once again I repeat it, the functionality of MER was, MER always holds the address of memory location, the location which is communicating with the CPU. So that's why here the CPU generated address first I transfer to MER. Why? Because this MER is directly connected to address bus, so that it will simply place whatever the address the CPU was generates on my address bus. So that is the meaning of this particular one. At the same time, the processor uses the control lines of the memory bus to indicate that read operation is needed. Once we place MER address on my address bus, at the same time what my CPU can do is, it will go and generate a read control signal. The read control signal or CPU transfer to the memory with the help of a control bus. That means here we have three buses that exist in my system bus. Here that bus here I can call as a memory bus. In that I have a address bus, data bus and control bus. Once my MER address is placed on my address bus, at the same time my CPU generate a read control signal to go and read a data from that address specified on my address bus. So that is the meaning of that. When the requested data is received from the memory, they are stored in a register MDR from where they can be transferred to other registers in the processor. Once you send an address, once you send a control signal, by receiving of address and a control signal, memory have an idea that the processor wants from so and so location information. It simply places that location information on the data bus. So once you place the information on the data bus, that can be collected by the CPU. The collected information it can store on one of my CPU register, which is called memory data register MDR. Thereafter, I will transfer to one of my CPU register, which will be treated as a destination for that data transfer. For example, my aim is, I would like to go on to read a data from a memory location 2000H. This location data I would like to transfer to my CPU register some R4. This was my aim was. In order to read a data from a location 2000H, first my CPU has to generate a 2000H address. This generated 2000H address I transfer to MER. Later from MER it is placed on to address bus. At the same time my CPU generates a read control signal. By receiving of an address as well as a read control signal, my memory have an idea that the CPU wants a data from a location 2000. It will simply place that location data on the data bus. Then my CPU receives the data from a data bus. The received data, it is copied onto register MDR. So thereafter, I would like to transfer the value to register R4 because R4 was my destination, not MDR. So once I receive a data from memory, no doubt initially the data was copied onto memory data register. Sometimes this is also called as memory buffer register. Once the data was stored onto MDR, later wherever if you want to transfer to any one of my CPU register, I can transfer it later. So in this example, my data was transferred to R4. So once my data was there in this MDR, from there it will be transferred to register R4. That is the way how my data was read from memory. Right? So this is the sequence. So address into MER, issue a read operation, data into MDR. See here friends, how my MDR is loaded with data. So once the data is available on this bus, data is available on the bus because this is I can call as memory bus data lines. That means this is nothing but the data bus which was present in the system bus. This data want to copy it into this MDR. Here important thing is the data was moving like this. If the data want to copy onto this, here this MDR in E, here E represents external. So that means we are receiving a data from external where that is from a memory location that through the help of memory bus. So that if I activate this, that means I make this is equal to 1. Whatever the data that was exist on this data lines, that was copied onto MDR. Once the data was stored onto MDR, I have to transfer the same data to, based on the previous example, register R4. This register R4 also connected like this. Here I have a control mechanism which can be controlled by R4 in. And if I read a data from this register, again I use a control mechanism. This can be controlled by R4 out. If I want to transfer data to this R4 register, which I was received from the memory, in that process, whatever the data that was exist on this, that is copied onto this MDR only when this MDR INE is set to 1. Now my data was copied onto this. From this I would like to transfer the data to register R4. If I want to transfer that, first this data information is placed onto this internal bus of my processor. In order to place the data on my internal bus of processor, this MDR out is set to 1. If it is set to 1, the data is goes to like this. Then it is placed on this. From that data is transferred to register R4. For that purpose, this R4 in is set to 1. Then the data was copied onto this. This is the way how your data was transferring from external bus, that is from memory bus, data bus into MDR first, later it will be transferred to the required destination. So this is the way how the data was transferred. Right. Here the response time of each memory access varies. If I want to access the information from any memory location, the accessing times are different. Why? Because sometimes you are accessing your information from cache memory. Sometimes you are receiving information from main memory once a cache miss was exist. In that case, which address mechanism our CPU was used? It may use a memory mapped IO or it may be use IO mapped IO. Based on all these things, the response time to access an information from the memory location was varies. That is, it depends on where we are accessing our data. So that is the meaning of that. The processor waits until it receives an indication that the requested operation has been completed. Your CPU has to wait. Once it issues an address, once it issues a control signal, it has to wait. Whatever the task your CPU has to assign to the memory, if that indication is given by the memory, I finish your task, your memory inform that information to the CPU by issuing of an acknowledgement signal. That here what we can call is MFC, which is nothing but memory function completed. Once it receives MFC signal, then and only your CPU have an idea that whatever the task that I was assigned to the memory, it finishes that task. So that is the meaning of this. Next, the addressor device sets this signal to indicate that the contents of a specified locations have been read and available on the data lines. When it was generated, and who will generate it? This is generated by the device who do the task. That means your CPU assigned a task to the memory. Once your memory finishes a task, your memory itself only has to generate the signal, MFC. And one more thing, when it was generated, whenever your CPU want a read operation on so-and-so location, once it places the data on the so-and-so location onto data bus, then immediately it will generate MFC signal. That indicates that whatever the task you are assigned to me, I finished it. You are asking your data from a particular location, that location data was placed already on the data bus, you can go and accept it. So I done my task, that's why I was generating MFC signal. MFC means memory function complete. So this is another information, you have to remember this. Right. To get a clear idea about this, here I took an example. So here my instruction was move in brackets of R1 to R2. Here my operation is read, a read operation. The meaning of this one is read data from a memory location whose address is specified by R1 into another CPU register R2. So the meaning of this instruction is move in brackets of R1 comma R2. That means whatever the location address that will be pointed by register R1, that pointed location data was transferred to the CPU register R2. So in order to execute this, what are the sequence of operations are performed internal to my CPU? So if I think in that direction, the first one is whatever the address that was there in a register R1, I would like to send that address to the memory. And didn't send that address straight away from register R1 to the memory through the address bus. That's why I place the address of a memory location which is available on a register R1 to first MER. So that I was doing here. The content of register R1, I was transferred to MER register because MER is a register which is directly connected to my address bus. Once the address is stored onto MER, it simply places that address onto address bus. What my next one? Start a read operation. Immediately your CPU generate a read signal. I want a data from a so-and-so location whose address is now available on the address bus. So that's the indication of that. Wait for MFC from the memory. I'm already told you MFC means memory function complete. Once your memory receives an address, once it receives a control signal, according to that it will do the task. Here the task is your CPU want data from a so-and-so location. That address is placed on address bus. Later it will generate a control signal read. Once these two are received by the memory, it places the location data onto the data lines. Then immediately it will generate a signal which is called MFC. Once your CPU receives MFC signal, then and only it have a clarity. Whatever the task was assigned to the memory finished the task. Here the task was the CPU wants some data from a memory location, so your memory places that location information on data line. So here what my processor can do is wait for MFC from the memory. Later what it do? It will go and took the data from a data bus, it is copied onto MDR register. That's what I am doing here. Load MDR from the memory bus. But that is not a destination. Here the destination was one of my CPU register R2. So once my data was stored in MDR, Why it is only stored in MDR? Because MDR is a memory data register which is directly connected to my data bus. That's why whatever the data I was received from the memory, that is copied onto MDR. Later the same information I was transferred to my destination register R2. So as a fifth operation, the content of MDR was transferred to a destination register R2. So like this, to execute our instruction move in brackets of R1 comma R2 was performed in my system itself. Right. So to do this, what are the control signals? The sequence of control signals, and what is the sequence? So memory read operation requires 3 steps. What is the first step? So R1 content I transfer to MER. So in order to transfer R1 content to MER, R1 out signal must be activated. At the same time, MER in signal must be activated. Then and only my R1 value was copied onto MER. If I place MER, my address from R1, immediately it will be placed onto address bus. At the same time, I would like to generate a control signal read. So with this, from a CP end to the memory end, the signals are transferred. Next, what happens? Your memory places the address and location information on the data bus. Immediately it will generate MFC signal. So here, wait for MFC. So once you generate MFC signal, then your MDR registries capture the data what is available on the data bus. In order to capture it, it needs a control signal that is MDR in E. I am already told you this E represents external, because here I was receiving the data from external memory through my system bus. In a system bus, I use a data bus dedicatedly to receive a data from the memory. So in order to copy whatever the data that was present on my data bus into MDR register, no doubt this control signal is active. So once I receive this MFC signal, I have a clarity that the CPU finishes a task and it will place a data on the data bus, so I can go on to get data. So to get data, I must activate this MDRINE. So as a last operation, already I have a data which I already received from my selected memory location. That data I would like to transfer to my destination. That's why MDR out must be activated. So then MDR value is placed onto internal bus. From there it will be transferred to my destination register R2. In order to copy the value which is available on my internal bus onto register R2, I must activate a signal R2 in. Then and only my data was copied onto register R2. So this is a sequence of steps. So what gives an indication for me is how my instruction was executed with the activation of different control signals. Here my instruction was move in brackets of R1 comma R2. So that's the meaning of this particular one. So next, a reverse operation to read, that is storing a word from memory. Previously reading a word from memory, now storing a word into memory. So here storing a word, that means writing a word into a memory location, which is similar to previous operation. The procedure what I was used in previous case to do a memory read operation, that is a memory fetch operation. The same type of procedure I was used to do this storing a word onto a memory location. This is the meaning of this. The desired address is again loaded onto MER. Once address is loaded onto MER, MER address is placed onto address bus, and immediately data to be written are loaded into MDR. Whatever the data I would like to transfer to my selected location, I first place the data onto MDR, and the write command signal is activated. That means 3 buses here I was used. The first bus is address bus, second bus is the data bus, and third one is control bus. Why? Because MER information is placed onto address bus, MDR information is placed onto data bus, and the write control signal is placed onto control bus. Once I place these 3 information on these 3 buses, now that can be received by the memory, and it will hold the received data onto the addressed location. So the instruction which is used to do this is, if I want to do this, what my instruction was. So here my instruction was is move R2 comma in brackets of R1. That means move the content of a CPU register R2 to the memory location whose addresses are specified by another register R1. So for execution of this, what is the sequence of operations we can perform? The sequence of operations in execution of an instruction move R2 comma in brackets of R1. What my first instruction? R1 address must be placed onto MER. For that, R1 out is activated. At the same time, MER in is activated. Once MER in is activated, R1 value was copied onto MER. From there, it is placed onto address bus. What is second one? R2 out. So R2 out comma MDR in comma write. That means R2 out. That means I am activating this. Whatever the value I have in a register R2, I must go and send that data to MDR. Because the meaning of this instruction is transfer the content of a CPU register R2 to the memory location whose address is specified by R1. So with the help of address bus, I transfer my destination address which is exists on R1. Now I am transferring my data to the selected location through MDR. That's why R2 out, due to this control signal, R2 value is copied onto MDR register, and thereafter I will generate my control signal right. Then what happens? MDR value is placed onto data bus, MER value is placed onto address bus, and then my control signal write is activated. So then here important thing is MDR out E must be enabled, because MDR value is placed onto my external data bus. So for that I must activate this. Thereafter I must wait for the signal MFC. So what is the use of this MFC? Whenever my memory was successfully receives the data through the data lines, then it will generate MFC. MFC is a memory function complete. That's the meaning of this. So the next one is execution of a complete instruction. How my processing unit can execute an instruction completely. Here the meaning of execution of instruction complete means, in order to execute an instruction, first of all what we have to do is, you have to go and fetch the instruction. Once you fetch the instruction, later you decode the instruction, then and only you are executing the instruction. In previous case I am not saying that fetching of the instruction, all these things straight away. I can go and discuss about execution of instruction, but now I can go and observe how a complete instruction was executed. That means in this execution process, how my system can do a fetching, thereafter how it can do execution. So for that I took an example, add in brackets of R3 comma R1. The add in brackets of R3 comma R1 instruction adds the contents of memory location whose address is appointed by register R3 with the content of register R1. Again the result may be stored in R1 or it may be a result was stored finally in register R1. So in that case the execution of this instruction requires the following steps. In the execution, in the sense I start from a fetching and I said once my result was copied onto a destination register R. So what my sequence of actions? The first one is fetch the instruction. That means first I have to go and fetch this instruction from the memory, where this instruction actually available in my memory. Once I fetch that instruction from the memory, later I have to go and execute it. So for that first action is fetch the instruction, then fetch the first operand. If I fetch this instruction, later I decode it. After decoding I have an idea that one of the data for the addition is available on the CPU, another data is not available on the CPU, it is available on the memory. So I can go and get that data. So for that here my second operation is fetch the first operand. That is nothing but the content of R3 specified location. So the contents of a memory location pointed by R3. Once I receive that memory location data which is pointed by R3, already R1 data is available for me, straight away I do addition. So perform addition and load the result onto the destination register R. These are the actions that are going on in the execution of an instruction and in brackets of R3 comma R1. So to do that, these are the different control signals which are involved in do this, all these things. So you can go and check it. So step 1, what I try to do is PC out. What is this? First step what I am saying is, I have to go and fetch my instruction from the memory. In order to fetch an instruction from the memory, that instruction address must be generated by PC. So that the PC generated address is placed onto the bus itself. For that, this PC out signal is needed. But here the PC value is not directly goes to external bus. It is first goes to the internal bus. From that it is a transfer to MER. Later it will be transferred to external bus. So here I was activating MER in. So by using of this, what happens is PC value is a transfer to MER. PC value is a transfer to MER. And later what I have to do, I'll generate a read signal because I'm going to read an instruction from the memory. So that I generate a read signal. And here a select 4. If you refer this as structure, once I send an address to the memory, what the job on my PC? PC has to go and point a next instruction. In order to point a next instruction here, I assume that my instruction size is a 32-bit. If it is a 32-bit, it occupies the 4 locations. So that's why in order to point a next location address by my PCU, the PC value must be incremented by 4. In order to do this, I must select a constant 4 like this. Later add it. That means whatever the value that was present in a PC value is added to 4. And whatever the result that I was getting at output of this ALU, that is placed on that, and later it will be transferred to PC again. So in that process I can go for step number 2. So here what happens is, so through Y or through bus I may receive PC value. For example, here I receive PC value from the bus like this. Okay, next thing is I select constant 4. That means here I was getting 4. This ALU division between these two by activation of this add signal. Then PC value I was getting at an output that was copied onto Z by activation of Z in. Later the same value was transferred to PC. So in order to transfer the Z value to the PC, first the Z out signal must be activated, and thereafter PC in must be activated. PC in must be activated. If it is do it, then what happens? In the meanwhile, I receive something from external memories. So the data was copied onto Y in. I activated a control signal, that is a memory wait signal. That means I wait for certain amount of time to read a data from a memory location. Once my data was placed onto data bus, I'll go and catch it. So in this case, MDR out, then IR in. That means I receive an instruction from the memory that was copied onto MDR. Later that was transferred to instruction register IR. So with these 3 steps, I identify that instruction fetching is over. Because I read an instruction from the memory before execution. In order to do this, I took these 3 steps. I used these different control signals. And thereafter I start an execution of my instruction. What my instruction here is addition, right? So in order to do that, R3 out, MER in, and then read. What my instruction here is? Here my instruction is this, add in brackets of R3 comma R1. That means one of the data is available on my CPU, but I wait for the second data. The second data is from a memory. That the memory location address is appointed by register R3. So that R3 value I would send it to MER. So that R3 out, MER in. That means R3 out, that indicates R3 value was transferred to MER because here MER in. And immediately I will generate a read signal. Then I wait for certain amount of time. Once this signal is active, that indicates that the data is available for me, right? The data is available for me. Meanwhile, what I try to do is, I am activating R1 out. That means I can go and take the data from R1. So through this register Y. So R1 out, Y in. So this data I receive. Here I may get R1 data. I was waiting for R3 pointed location data, which is a B data. So that I was do in the next one. MDR out, that means MDR value is a place, then select Y, add and Z. MDR out, that means MDR already receives a data from external memory. That is confirmed once I receives MFC. If MFC receives, that indicates that the location data is placed on the data bus, that is copied onto MDR. Then MDR data I would like to transfer to the second input for B. Second input for ALU as a B input. In that process, MDR out. At the same time I select Y, because the select Y is nothing but A input, and then I generate an add signal, because here my operation is addition, and it will produce a result of addition that was copied onto Z. In order to copy that value onto Z, Zin signal is needed. So by execution of this sixth step, what happens is I complete addition between the memory location whose address is pointed by R3 with the content of register R1. Temporarily my result was available in Z, but it is not my permanent destination for this instruction. This instruction permanent destination was the register R1, so that I have to transfer the content of Z to register R1. That I do with the help of last step. Z out, R1 in, and then termination. End of the operation. So if Z out is active, that means Z value is placed on the bus. If R1 in is active, that means whatever the data that was exist on this internal bus, that was copied onto register R1. So with that, my instruction execution is finishes. That means first 3 steps are related to instruction fetching, last 4 steps are related to instruction execution. So I hope you understand how an instruction completely executed. That means in this I do a fetching and later I do execution. So this is for today's topic. Thank you for patient listening. So in the next class we will discuss another important topic. Thank you once again for patient listening. Thank you very much.